In this video, we want to work on 9 ideas, 14 homeworks of 2022 COMC, Canadian Open Mathematics Challenge. We will work on last problem of this exam, part A, part B, part C. We consider some ideas, casework problems, problems of AMC as homework, promise problem, Harvard MIT Math Tournament problem, and then I will tell you here. Let me show you another ideas, for example, ghost idea, rainbow idea, a number of positive divisors, sum of positive divisors, product of positive divisors, problem from homeworks from AMC, again AMC, and then up to here 10 homeworks. Then we will work on rest, and here I will tell you consider a small example, number of primes and the powers, caseworks, and for example sum of xi's when they are at least 0 and equal to n number of solutions equal to what, and we will solve this problem. And I will leave last part as homework. It will be homework what? Homework, let me tell you, last homework will be homework 14. Okay, if you want to learn other ideas and want more homeworks or want to know the solution of homeworks, or we have around 40-50 important formulas in each topic, combinatoric algebra, number theory, and geometry. If you want to learn those 40-50 important ideas in each topic, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, let's start. Okay, 2022 COMC, let's consider some problems. Let's jump into hardest problems. Let's see, it is problem C3, C4, and there is no problem after that. Okay. It says an integer container XYZ is a rectangular prism and with positive integer. Okay, positive integer lengths, side lengths, XYZ, and x less than or equal y less than or equal z, and a stick has x equals y equals 1, a flat has x equals 1 and y greater than 1, and a box has x greater than 1. There are 5 integer containers with volume 30. One stick, okay, it says x1, y1. Volume is what? Product of them. So when it is 1, 130. Flats x equals 1. The product should be what? Y greater than 1. And so z is less greater than equal y. So y is 2, 215, 310, 4 we cannot have, 5, 6. Okay. And the order is like this. X, it is increasing. X less than or equal y less than or equal z. And one box. Box means what? X greater than 1. So it's 2. The only possible case 3, 5. Okay, it was an example to understand problem better. Part A. How many sticks, flats, and boxes are there among the integer containers with volume 36? So it is a casework problem. And let me write idea 1. Casework problems. And for this casework problem, one homework is AMC 2022. We had 2 problems. Homework 2, I will tell the exact problems. And also one problem of SUMAC 2022. 2022, last problem, Q8. And also one problem, homework 4. One problem of promise. The problem that has A of n, G of n. A of n is mean of sum of positive divisor. G of n is nth root of product of positive divisors. You can find that problem, promise 2022. Homework 4 and homework 3 are for USA summer camps, prestigious summer camps. So much useful for applying top universities. Homework 1 and 2, AMC 22 problems, and homework 5. One problem from HMMT 2023. Harvard MIT Math Tournament. All of them can be solved with only caseworks. Okay, so let me explain. Let me tell you the homework 1, homework 2, exactly which problem. Okay, for AMC 2022 12A problem 24, it is a casework problem. For AMC 2022 12B problem 18. Again, it is a casework problem. So try these 2 problems. So I told you these two problems are what? Sumac problem, last problem, promise problem I've explained. For Harvard MIT Math Tournament, I should find it. Okay, so if you want to know that problem or want to learn 40, 50 important formulas in each topic, combinatorics, algebra, number theory, and geometry, feel free to send message to my WhatsApp number in the description and comments. Okay, so here let's see how we can apply case one. Part A. Let's solve it in a new page. Okay, for part A, the product should be 36. We consider caseworks. First case we consider for sticks. How many cases are there? Okay. So we know for sticks, xy equals 1, so it is 1, 1. The product is 36, so last one should be what? 36. So how many cases are there? One case. Now let's consider second case. Second case is what? Flat. In flat, what's the property? X is 1 and y is greater than 1. So it is 1. Second case is can be 2. Let's write the cases. Because the product is 36, y should be a divisor of 36. So 3 is possible, 1, 4 is possible, 5 is not possible because 5 is not divisor of 36. 6 is possible, so if we write 2, 18, 3 times 12, 4 times 9, and 6 times 6. Okay, the product is what? 36 for all cases, and because y is less than or equal z, so we cannot write any other cases. So how many cases are there? 4. Third case in our case works. If it is box, x should be greater than 1 here. So x can be 2 or x3. If x is 4, if you select all of them, for example, like y and z, x, y, z is what? Then is at least 4 cubed. Because it is less than or equal this, less than or equal this by assumption of the problem 64. But we know x, y, z is 36, so it is not possible. Okay. So we should only work on 2 and 3. Let's check case 3 first. The product here should be what? Should be 12 to reach 36. So if it is 3, it is 4. If it is 4, it's not possible. Because then this one should be at least 4. Then we cannot reach any good case. So we've solved for this part. Now here. The product here is what? 2 times what? 36, 18. So it can be 2 because it is at least 2. 2 or 3, 18. So 2, 2, 9, 3, 6, 18. And it cannot be 4, it cannot be 5. So the only possible cases are these 2. 1 case, 3 cases. So 3 cases, 4 cases, 1 case here. Okay, so 1 stick, 4 flats, 3 boxes. We solve this problem by considering casework. How, for example, here you say x1, y is 2, 3, we split into smaller cases. But it was not hard problem of casework part A. As you can see, part B 210, probably it should be harder. How many flats and boxes are there among the integer containers with volume 210? Sticky was easy. It is 1, 1, 210. So here it wants to only calculate flats and boxes. Okay, so let's try. Okay, for this part, we want to find flats and boxes that the volume is 210. So before writing, it's good to write divisors of 210, positive divisors. You write, okay, 1, 2, 3, 4, not 7. If we prime factorize, it is 2 times 3 times 5 times 7. So it is 2 times 3, 4, no 5. It's okay, 6, 7, 8, no 9, no 10. And then 11, no 12, no 13, 14. 14 is okay. 15, 3 times 5. 16, no, 17, 18, 19, 20, 21. 21, okay, so 21 times 10, 14 times 15, Now we can use Gauss idea to write the rest. Okay, because for example, when you write 1, 210. We call this idea, let me write it, Gauss idea or rainbow idea. Or rainbow idea. There is a problem. Let me see how many homeworks did we have. 4, 5. Homework 6. There is a problem of IMO that can be solved with this, but I should check the year, okay? If you want to know exact year. In my previous video, I found that it was for what year. You can check them, or if you want to know exact year, feel free to send message my WhatsApp number in the description and comments. Okay, 2110 and 7, 2 times 3 times 30. 6 is what? 35. 5 is what? 42. 3, 2 times 5 times 7. It's 70. 2, 105. 1, 200. And let me tell you something. For checking, maybe for example, we have careless mistake and we ignored some of the divisors. So how can we make sure? Idea 3, number of positive divisors. Number of positive divisors. You say, okay, for example, when the powers are 1, you add 1 plus 1. Why? 1 plus 1 times 1 plus 1. Because you say, okay, the divisor can be 2 to the 0 or no 0 or 1, 2. No 2 or 1, 2. 3 to the 0 or 3 to the 1. 1 plus 1, 1 plus 1. 2 to the 4 is 16. So let's check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So we've written all divisors. Now it helps us. Also, we have formula for sum of positive divisors, and we have formula for product of positive divisors. Positive divisors. Okay, and let me tell you homework 6, homework 7. Sum of positive divisors, if n, for example, is p1 alpha 1 to pk alpha k, number of positive divisors is t alpha 1 plus 1 to alpha k plus 1, exactly by the same proof, p1 or p1 squared or p1 cubed to p1 alpha 1. Sum of positive divisors is 1 plus p1 squared to p1 alpha 1, and you can write it up to 1 plus pk squared plus pk alpha k. So you can use also these formulas for the homework I told you for Promise Summer Camp. Let me show you on this problem, homework for Promise 2022. Homework. This one, product is n to the power of t over 2. And you can prove it as homework 7. Try to prove it. But why it is this? Try to use Gauss idea. Homework 8 and homework 9. 2 AMC problem that you can solve with this idea. Let me tell you those problems are what? Okay, homework 8 is this problem. Homework 9 is this problem. I told you 2 problems of AMC. Homework 10, it is related this one, number of positive divisor. We have also one homework from AMC that is related to sum of positive divisors, okay? I should search this, and if you want to know exactly the problem was what, you can send message to my WhatsApp number. And here I told you 10 homeworks. For this one, why sum of positive divisors equal this? You can try to prove it as homework 11. Okay, and if you had question, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, so now let's focus on this part. Okay, by our case works, let's consider first we have flats, okay? We have flats, and it is what x is 1, but y is not 1. So we can say 1, 2, because 2 is the divisor of 210. 1, 3, 1, 5, 1, 6. We can go up to which number? 14 times 15 is 210. So 1, 6, 1, 7, 1, 10, 1, 14. Okay, and the next will be obvious. 2 times 105 3 times 70. From here, we go backward. 42, 5 times 42, 35, 30, 21, and 15. Okay? So 1, 2, 3, 4, 5, 6, 7. So it is 7. Now we want to see how many boxes are there. So case 2 box. The first one should be at least 2. Okay, so if it is 2, we know there are x less than or equal y less than or equal z. So in the box, we know that x is greater than 1. The product is 210. So if it is 2, the next one can be 2, or next one can be 3. The divisors. Sorry. 210 is what? If you prime factorize, is 2 times 3 times 5 times 7. So we don't have two twos. So 2 is not, 2 twos is not possible. 2 3, 2 5, 2 6 again not possible because we don't have two twos for 210. 2 7, 2 8 9, 2 10 11. Let's check the divisors. We've written 2 7, yes, 2 10, 2 14, they are even. 2 15, from here also you cannot write 15 because then next one is also at least 15. Then 2 times 15, the product will be at least 2 times 15 times 15, which is 450. It is bad, okay? Now let's start from last case, 2 7, okay? If we consider 2 7, what thing is left? 3 5, because the product is what? 2 3 5 7. You have 2 7 3 5 is left. So the last one we can say also like this. The last one is unique. 2 7 15. 2 5 because we know it is 2 3 5 7. So when we have 2 5, 3 times 7, 21 is left. 2 3 5 times 7, 35 is left. Okay? So we've considered all cases that it starts with 2. Now if it starts with 3, the next one is greater than 3. So it should be what? 4 is not possible. 5, 3 5, or 3 6 not possible because we have 3 here. 3. Why I say 3 6 not possible? Because when you write 3 6, the product is multiple of 9. But 210 has only one 3. 3 7, 8, 9, 10. 3 10. Then it is 3 times 10. So then this one is at least 10. So the product will be at least 3 times 10. The product times 10. It is 300, but we want to reach 210. So 3 5, it will be what? 14. 3 7, 2 times 5, 10. Okay, so we found two other cases if we start with 3. Okay, let's move this bad case here. Now, next case, we start with 5. Okay, next one can be 6, or next one can be 7. Okay, if it is 5 7, the next one will be 6. It is bad. Okay, because the product is 210. If it is 5 6, then next one is 7. So it is the last good case, because if first one is 6, then this one is at least 6, this one is at least 6. 6 cube is 216, which is greater than 210, so it's not possible. So 3 cases here, 2 cases, 1 case. 1 plus 2 plus 3 is what? Is 6. So 6 cases for these, 7 cases for these. 6, 7. We could also solve this problem with easier solution. For example, for flats, you say, okay, it is 1. So when we want to select, it is 2, 105, 3, 70 up to 14, 1, 2, 3, 4, 5, 6, 7, as easy as this. Like also next one. But all of them related to casework. Some of them easier, some of them harder. But we want to solve them only with logical solution so that it will be useful for other problems. Okay? Now one part of this problem is left. Is what part? C. Suppose n equals p1 e1 to pk to the ek has k distinct prime factors p1 to pk, each with integer exponent e1 to ek, all of them at least 1, and k is at least 3. We have at least 3 primes. How many boxes are there among the integer containers with volume n? Okay, and express your answer in terms of E1 to EK. How many boxes with volume n equal to 8 factorial are there? Okay, for these types of problem, this idea also especially useful in SUMAC. How many ideas did we have? 5 ideas. I6, considering small example, but here, considering small examples, but here, because we have many problems similar to this, let me extract an idea. Work on number of primes. Here we have, for example, here it says at least 3 primes, consider 3 primes, then 4 primes, and the powers. When we have 3 primes, for example, powers are what? And something like this. So here let's try. At first, let's consider we have 3 primes. It is P1, E1, or here it says K at least 3. We can also consider 1 prime, 2 primes for ourselves to understand problem better. Okay, but let's start first with 3 primes. If it was hard, we work on 1 prime. Okay, and on how many homeworks did we have? 10 homeworks. Also 11 for proving this, proving idea 4. Homework 12. One problem of SUMA can be solved with this idea 2022. It is related to prime numbers. And homework 13. Q25 of AMC, I don't remember, it was for 2021. Which part can be solved with this? It is, for example, DN. It has DN, okay? We can solve them. Now let's work. See how many boxes do we have? For P1, E1, P2, E2, P3, E3. We know that X, we have X, Y, and Z. X is less than or equal Y is less than or equal Z. And we know X is greater than 1, okay? So here we can write, for example, 3 primes. Consider a small example or example with respect to k. Or here, because problem says calculate n 8 factorial, we can work on 8 factorial. So you can check both of them to see which of them is easier. Now let's check 8 factorial, okay? Because the problem as an example to see it is what? Okay, let's write 8 factorial. We should first do what? We should prime factorize. And if we write it as 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8, it is 2 to the what? 1, 2, 3, 4, 5, 6, 7. 2 to the 7 times 3 to the 1, 2, 3 squared times 5 times 7. Okay? Now, we want that the product of 3 terms equal to 2 to the 7th, 3 squared, 5 times 7. So let's write x, y, z equal to this. Okay, now, at first we don't consider that, we know that x should be less than or equal y, less than or equal z. Now, if you don't consider this and calculate all answers here with also permutations, what happens? We calculate, for example, let me tell you an example. We calculate x, y, z, and now we don't want to focus on, for example, flats, boxes, sticks. We want to calculate all of them, okay? And then at the end, we will subtract sticks and flats. So when we want to calculate these, if we have, for example, 1, x1, 2, and then 8 factorial over 2. How many times do we count this case? I want to consider all permutations. 6 times, okay? If 2 of them be equal, for example, 1, 1, 8 factorial, how many times do we count this? How many permutation does it have? 3 permutation, or we calculate it 3 times. Can 3 of them be, so here 2 of them are equal. Can 3 of them be equal? If three of them be equal, then it is a. So a cubed should be 8 factorial. Is it possible? No, because then 8 factorial should be perfect cube, but power of, for example, 2 is 7. It's not perfect cube. So we don't have this case, we have only these two cases. Now, let's consider, for example, product of x, y, z. They have some power of 2. Let me write x, y, z equals 2 to the 7 times 3 squared times 5 times 7. Okay? So let's consider x, y, z, prime factorization of these numbers. Here we can say 2 to the a1, 3 to the b1, 5 to the c1, 7 to the d1. 2 to the a2, 3 to the b2, 5 to the c2, 7 to the d2. Z, 2 to the a3, 3 to the b3, 5 to the b3, c3, and 7 to the d3. Okay. Now, we know the product of x, y, z equals these numbers. So what can we say about ai's? a1 plus a2 plus a3 is what? Because the product is 2 to the 7. Powers of powers should be 7. b1 plus b2 plus b3 should be 2. C1 plus C2 plus C3 equals 1. D1 plus D2 plus D3 plus D3 equals 1. And AIs and all these things should be at least what? A1, A2, A3. All of them should be at least 0. Okay, so let's see how many cases are there. For D1, D2, D3, it's easy because you say, okay, 0, 0, 1, and 1 can be in 3 cases. 3 cases. This one, 3 cases. For B1, B2, B3, it is what? Let's write B1 plus B2 plus B3 equals to 2. So here we can say 0, 0, 2, 3 cases of this type. 1, 1, 0, again 3 cases of this type. So it will be 6 cases. And now let's focus on A1 plus A2 plus A3 equal to 7. So one way case work, one way also it has other solution. I will tell you it is what? It is 7, so you say 0, 0, 1 case. I consider case work of A1. So as an idea, we can say I8 here, we are solving with case work. Case work means what? For example, we consider a property and then split the solution into smaller cases by considering cases of that property. For example, here A1. If A1 is 7, we have one case. If A1 is 6, then it is 1, 0, 0, 1, two cases. If it is 5, it is 2, 0 to 0, 2, three cases. Up to, if it is 0, it is 7, 0 to 0, 7, 8 cases. So it will be what? It will be 1 plus 2, 8. And it will be 8 times 9 over 2, which is 36. Okay. There's my 36. But let me tell you another way. Here you say, okay, A1, A2, A3 should be 7. 1, 2, 3, 4, 5, 6, 7. We should have two dividers to create to this. So here, here. For example, this one is A1, this one A2, this one A3. So, it is a new idea. We want to work. So for 7, we say, okay, this we should calculate all permutation of these 7 balls and 2 dividers. So permutation with repetition, 9 factorial over 2 factorial, 7 factorial, or 9 choose 2. 9 choose 2 is what? 9 times 8 over 2, which is 36. So it is an idea, okay? For example, if you have x1 plus x2 to xk, which there are at least 0 equals n, the answer is what? You will see we have n balls and how many dividers? K minus 1 dividers. So it will be n plus k minus 1 factorial, n factorial, k minus 1 factorial. So it will be n plus k minus 1, choose n, or n plus k minus 1, choose k minus 1. Both of them correct. Okay, it was the idea also. It is for the case that xi at least 0. For xi at least 1 also we have another idea. If you want to learn all important ideas related to this, feel free to send message to my WhatsApp number in the description and comments. Okay. So it was 36,633. Now let's calculate the rest. Let me open a new page. So the answer for all x, y, z, that without considering the order, is what? 36 times 6 times 3 times 3. 36 times 6 times 3 times 3. And if we calculate, it will be what? So let's write like this first. And we said we calculate each of the cases like this 3 times, 6 times, this 3 times. So let's calculate number of cases like this. A, there are different number of cases that two of them similar. B. So we calculate 6a plus 3b. In this case, 6a plus 3b. Now we can divide both sides by 3. So it will be 2 here. So 2a plus b equals 6 times 36, 216. 3 times that. 3 times 6, 18. We have 1. 3 times 1, 3 plus 1, 4. 3 times 2, 6. And now, here we want to calculate what? We want to calculate a plus b. Okay. A plus b we want to see is what? Okay, then at the end we will subtract. A plus b is what? Number of sticks plus number of flats plus number of boxes equals a plus b. We calculate a plus b, then at the end we will subtract f and b. Okay. Now for here, it is what? We can say. mm, okay, so let's read first the property of box, and let me show you. Okay. Property of a stick was what? X and y equals 1. Property of flat is what? This. Okay, so let's first do something. Here we want to calculate a plus b. B is easier to calculate, means two of them are equal. So let's consider, for example, we said, okay, x, y, for example, 2, then z equals what? 8 factorial over 4. Two of them equal. Let's calculate cases of b. We consider x equals y. In B, we don't calculate permutations, so x equal to y is okay. And we know z won't be equal to x and y. Now, if we write again this formula, let me copy. We know that x and y are equal, so here we can write all these things and a as a1, b1, c1, d1. Okay. So we can say 2a1 plus a3 equal to what? 7. 2b1 plus b3 equal to what? 2. 2c1 plus c3 equal to 1. 2d1 plus d3 equal to 1. Okay. Now for this one, how many cases are there? Look, if you determine d1, then d3 will be determined. Okay. So d1 is 0. It cannot be 1 because then it will be 2. D3 should be -1. There are at least 0. So 1 cases here. D1, 0. C1 again, 0, 1 cases. B1 can be 0 and 1, 2 cases. A1 can be 0, 1, 2, 3, 4 cases. So B will be what? Will be 8. Now, we found that B is 8. So A is what? 648 minus 8, 640 over 2, which is 320, okay? So A plus B, 328, okay? So we found number of sticks plus number of flats plus number of boxes equal to 328, okay? Now let's calculate number of, for example, sticks. It will be what? 2 ones. 2 ones and 8 factorial, so 1 case. Okay, now let's calculate number of flats. Number of flats means what? One of them is 1, and We have two others. Y is it? Y should be greater than 1. So let's do something. We don't consider y greater than 1, so we consider sticks and flats together. So here yz equals to what? 8 factorial. Means 2 to the 7 times 3 to the squared times 5 times 7. And if we write y as we said, 2 to the a2, 3 to the b2, 5 to the c2, 7 to the c2, d2, and z equals 2 to the a3, 3 to the b3, 5 to the c3, 7 to the d3. Then we know a2 plus a3 equals 7, okay? And we can say what? We can say b2 plus b3 equals 2. C2 plus C3 equals 1. D2 plus D3 also equals 1. So here there are at least 0. How many cases are there? 1, 0, 0, 1, 2, 1, 0, 0, 1, 2, 2, 0, 0, 2, 1, 1, 3 cases here. From 7, 0 to 0, 7, 8 cases. So it will be what? 8 times 3 times 2 times 2. But because we know y is less than or equals it, and they cannot be equal, because if they be equal, then 8 factorial is y squared should be perfect square. It's not perfect square 8 factorial because powers are not even. So we divide by 2. If we cancel 2, 2, 8 times 3, 24 times 2, 48. And answer, which is boxes, in this case, is 328 minus 48. So it is what? It is 280. Okay, so the answer for 8 factorial is 280. With the idea I've told you, you should solve. Look, you can generalize 8 factorial. Now you've learned. You should pay attention somehow to perfect cube, perfect square. I told you all formulas. So try to solve for general n as homework 14 for general n. And if you had question about this, that how can we generalize 8 factorial to general n, because it will be exactly the same. But you should pay attention. Maybe n is perfect square or perfect cube. So you should change some small things. If you want to learn, if you want to know the homework 14, the answer of this homework or other homeworks, or want to learn more ideas, or want to learn 40, 50 important ideas and formulas in each topic, feel free to send message to my WhatsApp number in the description comments. Okay, thanks for watching this video. Have a good day. Bye.